Okay, so just for the recording purposes, I'm just going to mention one more time. We're not going to go through the whole quiz. We're going to go through just the problems that the majority of students missed, or more, like I would say, more than 20% missed, right? I'm sure there's problems out there that random people missed that I'm not going to go over today. But the answer keys are all in Schoology, and of course you can come in. By the way, I am still getting emails from students asking if they can come in before or after school. Don't send me an email. Like I truly don't want an email. I actually just want you to come in. I'm always here. Like I live in the MRC. So honestly, please, as a matter of fact, I used to have students who came in every single day all year, right? Like every single day. I had one student who was first in his class, like straight A student, who came to the MRC every single day and asked me questions. I love that. Believe it or not, I actually really enjoy doing math. And so I love helping students with questions. It's like one of my favorite things in the world to do. So please, please don't ever be afraid to come in if you have questions, because I love sitting with students and helping them with questions. Yes, Elise?
What time do you normally get here in the morning?
So I'm going to rephrase your question to, what time do you like to start helping students in the morning?
Yeah.
Okay, so the time that I like to start helping students in the morning is 7:15. I normally get here 7-ish, right? But I like to have some time, like personal time first. And then 7:15 to 7:45, door is open for, questions or whatever. If you get here early and ask for me, I'll say, sure, tell them I'll be out there in a minute, and I'll keep checking my emails and getting my coffee until 7:15, and then I'll come out. After school, I always say at least till 3:30, and sometimes you can even push me to stay till 4, right? So anyway, and I used to have students, like a group of students, who would come in every day after school, sit in the MRC, and just do the homework together, right? And it was kind of like little study groups. And then if they had any questions, they could just yell through the door, Mrs. Price, right? And I'd come out and join them and help them with whatever they were stuck on. And they loved it, and they did well, right? So there's a lot of things you can do together to help each other, right? And you can use me as well. The only time I'm truly not available is Tuesday mornings, right? Because we have department meetings. But apart from that, I'm here. Okay, so that's the little side discussion. Moving on. So I am skipping A because just about everybody got it. Most of you know how to factor, so that's good. We are going to jump right in to this guy. Okay, I tell you true. You will have to know how to convert from absolute value to piecewise on your test. You won't be able to get around it. Well, I mean, unless you want to just lose the points, right? But apart from that, you won't be able to get around it. So let's convert from absolute value to piecewise. So instead of rewriting the limit, I'm just going to rewrite the function over here and write it as a piecewise. So when I write something as a piecewise, the first thing that I do is I set the guts of the absolute value equal to 0. And whatever number I get, in this case it's x equals 1, that's the number that becomes what I call the splitting point, or the whatever you want to call it, the handoff point. So you're going to have something greater than 1 and something less than 1. The equals can go either way, it doesn't matter. It's the greater than and the less than. All right, so that's how you get that number, right? You just set your guts equal to 0, solve for your number, and that goes there. Now, what goes here is going to look exactly like this. The only difference is that none of it, the absolute values will be gone, and one of these will be negative. So if you start right in and write 1 minus x over x minus 1 and 1 minus x over x minus 1, you'll be at least half right. Okay? Now all we have to do is figure out which one becomes negative. The one that becomes negative is the one where if you plug an x into the absolute value stuff, I call it the guts, into the guts, you would get a negative. So if I pick something greater than 1 like 2, 2 minus 1 is positive, so that stays positive. If I pick something less than 1 like 0, 0 minus 1 is negative, so this guy gets a negative sign. Because when you're, like, if you have an absolute value, the absolute value of negative 5 is 5. It's the same thing as multiplying the negative 5 by negative 1, right? So the absolute value, when you get a negative number, essentially just says take the negative number and times it by negative 1 to make it positive. All right, now personally, I would simplify this. You technically don't have to, but it's kind of hard to do the limit without simplifying. This was tricky. There's a lot of negatives, like there's a lot of double negatives in here. Does anyone know what 1 minus x over x minus 1 equals? It equals negative 1. Because if you think about it, this guy right here, that's the same as negative x minus 1, right? So it's really like negative x minus 1 over x minus 1. So the top is just negative 1. On the bottom, hey, negative x minus 1 is the same as 1 minus x. This is just 1 minus x over 1 minus x. So the bottom simplifies to 1. 1. Thank you. That's part 1 of this beautiful problem, right? We still haven't found the limits. Now, in order to do a limit, whenever you have this like greater than, less than thing going on, whenever you have like one of these kinds of problems, you have to do a left and a right. There's no way around it, and I want to see it on your paper. You have to do a left, and you have to do a right. So it's the only way to find the limit. All right, I know it's easy. I know you know the limit doesn't exist, right? I know we can all do it in our heads. I'm not grading what's in your head. I'm grading what's on your paper. You've got to put it on your paper. So the limit, as x approaches 1 from the right, we'll do the right first. 1 minus x minus 1. So from the right, we're up here, so it's negative 1. The limit, as x approaches 1 from the left, 1 minus x over x minus 1 is the value. Okay, from the left it's 1. Therefore, the limit as x approaches 1, 1 minus x over absolute x minus 1 does not exist. Now, I was so nice when I graded this problem. I counted it for 2 points. Most of you, if you did some sort of work that looked like you were trying to come up with a piecewise function, I gave you a point. I don't usually give points for effort. On tests, I never give points for effort. You have to have stuff that's actually correct. But it's a quiz, so I was nice here. I gave you a point. Okay. Yes, Mohit.
So, like, when you plug in, like, your, like to find, like, which one, like, you put the negative on, you just do that for the part that was, like, an absolute value.
Correct. That's a very good point. So when you're checking to see which one you put the negative on, you're only looking at the guts of the absolute value. That's it. Right? The other stuff is what it is. Can't change that. This is the one that we're rewriting. Yes, Nishida.
If we get a problem like this on the test, so you would require us to have a piecewise function, right?
I might even say, write this as a piecewise function, just to ensure that you got it. Yeah. Okay. Good. Any other questions before we move on? All right. This one most of you got. Some of you didn't. I can go either way on showing this. Would anyone like, and this is where we don't want fear, all right? If you missed it and you really are struggling and you want to see it worked out, this is where you need to be your own self-advocate and say, Mrs. Price, I need to see this problem. Yeah. So, okay, there we go. So we're going to multiply top and bottom by the conjugate. All right. You guys, honestly, I'm very impressed at how well you've picked up on multiplying by conjugates. So root x plus 7 times root x plus 7 is x plus 7, minus 4 times 4 is 16. Do I multiply out the bottom?
No.
No. If you multiply out the bottom, you're gonna be miserable. You're never gonna see what cancels. All right. Lucky for us, the top simplifies to x minus 9. And then we have this x minus 9 here. And we get cancel, cancel. And as soon as you cancel top and bottom, you can just plug in. What's on top? 1. On the bottom, if I plug in a 9, I get root 16, which is 4, plus 4, which is 8. I don't know why I left such a big fraction. So there you go. The answer is 1. Yeah, whenever you see roots and you have to do a limit and you get it's a 0 over 0 limit, you're probably going to be multiplying by the conjugate. Okay. What you might want to do now, if you want, is have, you can make notes on, these quizzes are yours to keep, right? So if you want to write all over them, that's fine. If you want to circle things you need to say, that's fine. If you want to maintain another sheet of paper and make lists of topics you need to study, that's fine. Whatever you need to prepare for your test, right? Because this is one of your first times in a while that you got to do well first time out. You don't get to see the test and then, oh my gosh, I did poorly, I'm going to retake it, and then you get to retake the same test again. So this is where you got to remember to prepare to do well. Okay, so this one, I'm going to skip this for now. We'll come back to the try another ones if there's time, because it's tight for schedule, we're kind of short on time. Okay, this guy, I need to give you a warning. Never, ever, ever do I want to see decimals on your paper for a left and right-handed limit. A lot of you are writing 1.9s, and you're saying, hey, this is the same as the limit of 1 over 1.9 minus 1. Don't write that, because technically it's really an approved method for doing these. So what I really am looking for when you're doing these problems, I will tell you, Miss Grunwald's requiring her students to sketch a graph, and she's grading the graph. So for you guys, you're going to pick a number close. By the way, some of you are still picking close numbers like 1.9 and plugging them in for every left and right-handed limit you see. Why can I do that for this one? Because it's a vertical asymptote. How do I know this is a vertical asymptote? Because it's a not 0 over 0. That's the only time you pick one of those decimally numbers close. Anything else, don't do it, right? As a matter of fact, I'm truly seriously considering not teaching that method anymore, even though it's so nice and quick. I think I might switch to Ms. Grunwald's graphing method because so many students are doing it every time they do a left and right-handed limit. And it's not for left and right-handed. It's only for vertical asymptotes. And it's only because the answer is going to be an infinity. So here's what you do. So I'm going to go ahead and keep doing it, though, for this year. So 1.9 is to the left of 2. If I plug a 1.9 in on top, I get a positive. If I plug a 1.9 in on the bottom, I get a negative. Positive over negative is a negative. That's going to negative infinity. That's all I want to see. Is that good? Don't overcomplicate these. Okay. I should warn you, if you have something like this, which is a vertical asymptote, but it's not a lefty or a righty, then you have to do both. You have to check from the left and you have to check from the right to see if they match or not before you can tell me the limit. Okay. Okay, we're on the multiple choice section. Most people got this one. If you didn't, it's probably just because you've forgotten some of your trig, right? So we need to review our trig. The sign of pi halves is 1, but we need to know sign of 5 pi halves, so let's just think. So this is 1 pi halves, 3 pi halves, 5 pi halves. I'm back up here at 1. So the sign of 5 pi halves is 1. So this equals 1 over x's pi halves, which equals when you like simplify a fraction to a positive. All right, so there will be at least one on your test with some trig. So you might want to, if you are having trouble with trig, do a little Khan Academy review on trig, right? I can't give you a trig review, but you know, there's tons out there, believe me. So if you're having trouble remembering all of your trig values at your major angles, then you might want to just review them over the weekend. Don't spend a lot of time. It's not a million points. It's just like 2, but it's still something. Right? Okay. This one got people. So when you plug in the 1, so you get 1 minus 1, which is 0, negative 2 over 0. What's going on here? Vertical asymptote, right? Now, here's the thing. I have a hard time plugging in decimal numbers to a quadratic like that. So it actually is easier if you go ahead and factor. So I found it easier for this one to factor first, and then pick my number close to 1 from the right to plug in. So remember, if there were common factors, it wouldn't be a vertical asymptote. It'd be a whole, and we just do the limit, cancel the factors. But since this is a vertical asymptote, I'm going to pick like 1.1. So if I pick 1.1, so 1.1. So I plug that in here, I get a negative. I plug that in here, I get a positive. I plug it down here, I get a positive. So I have a negative times a positive over a positive. What do I get? Negative. This guy's negative infinity. Yes, Kostya. You sure?
Yeah.
Okay. Okay. All right. Good. All right. Another one. We really hammered the vertical asymptotes on this one, right? Okay, so this one, you plug in the 1, you get negative 2 over 0. But this one isn't a lefty or a righty, which means you got to check both. Now, just so you know, no one will ever check your work on a multiple choice. So if you have bad notation or horrible work or you don't show any work, it doesn't matter. Multiple choice, it's just literally, did you get it right or did you get it wrong? There's no partial credit. There's no grading of work. It just is what it is. Okay. So if I do the limit as x approaches 1 from the right, so I pick like 1.1, I get a negative over a positive. So negative infinity. If I pick something from the left, like 0.9, I get a negative over a positive. Negative infinity. Notice like the bottom's always squared. It's always going to be positive, right? So anyway, so this limit is negative infinity. A lot of vertical asymptote stuff. I don't think there's quite that much on the actual test, but there's some. So just be aware. Not 0 over 0. That's your key to know it's a vertical asymptote.
How many tests? Questions?
10.
Oh,
Okay? Okay. That doesn't mean it's these.
well, yeah.
Okay.
But
All right.
singular.
Okay. This was everyone's favorite problem. I could tell when I graded it that you guys just enjoyed this one so much, right? Okay. So the first thing I want to mention is what it's asking for. Make sure you read. This one's asking for the slope of the secant. Does the slope of a secant require a limit? No, a slope of a secant is the slope you've been doing since you were 10, right? It's just change in y over change in x. That's all it is. So those of you who are trying to do limits with this, you were trying to find slopes of tangents. Tangents require limits. Secants don't. So slope of a secant line connecting the point A, f of A, and A plus H, f of A plus H. Let's go ahead and write out what these points are. So the first point would be a. F of a would be 8 over root a. The second point would be a plus h for our x value. F of a plus h would be 8 over root a plus h. All right, so then your slope of your secant, subtract the y's. Over, subtract the x's. This was 2 points. The problem was 2 points. If you got this, that was one of the 2 points. The second point was getting it out of complex fraction mode. This was where the fun began. So all algebra, right? You're gonna like be upset when I show you what you have to do. So most of you knew to get this, to get rid of the complex fraction, you multiply the whole top and the whole bottom times the LCD. So what happens when we multiply the top by the LCD? So 8 over a plus over root a plus h times root a plus h times a. The root a plus h's cancel, and you're left with 8 root a. For this term times these, the root a's cancel, and you're left with 8 root a plus h. So I normally don't multiply out the denominator, but I am going to go ahead and just say that a minus a is gone, right? And just say this is h times, oh, I don't even need to see, it's all multiplied. So this is h times root a plus h times root a. Is this a complex fraction? No, I'm done. Stop. Okay? I even wrote on some of your papers, like, stop here, just stop, right? Stop and let it go. You have fulfilled the requirements of the problem. You need to walk away, all right? Some of you, like, went insane trying to simplify the heck out of this thing. It didn't require that. All it asked was give me the slope of the secant and don't let it be a complex fraction. Just be done. Something tells me that was quite the time consumption for some of you. Looking at the papers, yes. So I want you to learn how to stop and walk away. Okay. We're going to skip that for now. Okay, so the next one, IVT. Some of you just need to review the IVT, right? It was most of you kind of remembered, like, in the back of your minds, like, oh my gosh, like, this is that IVT thing, right? Just so you know, and I said this, and I told Ms. Grunwald that I said this, the problem on your test might not tell you in any way, shape, or form that it's an IVT problem. It might not even say the words use a theorem. It might just be some problem where you need to recognize, am I trying to prove that there's some y value in between two other y values, right? Okay, if that's what I'm trying to prove, it's an IVT. Okay. The first thing that you need to say for every theorem we learned this year is what? F of x is continuous. If you don't write that f of x is continuous, you are not going to get credit for your IVT. So, and you really should say continuous on the closed interval. That's the requirement of the theorem. F of x is continuous on the closed interval, and then check. You should even make the noise, right? Okay. The next thing you have to do is decide if the y value you're interested in, what y value are we interested in? 11. Decide if that is in between the y values of the endpoints. How do you do that? You got to find the endpoints. So you have to find f of 0, and you have to find f of 5. F of 0 is -1. F of 5 is 25 plus 5 is 30 minus 1 is 29. Does 11 fall in between these? Okay, the way we write that, f of 0 is less than 11, which is less than f of 5. Check. Check, check. Therefore, IVT applies. So now you can write your conclusion statement. You've just shown the hypotheses were met. Now you write your conclusion. So therefore, by the IVT, once you write those words, you repeat the problem. So I'm going to underline. There must be a value C on 0 to 5 such that f of C is 11. So you just rewrite it. Like there's nothing else to do. Don't think. Don't try to paraphrase. Just rewrite it. Be a sheep. All right. There must be a value C on 0 to 5 such that f of C equals 11. All right. Those 3 things, all of that was worth 1 point. You have to have everything to get the first point for IVT. By the way, if you don't name the theorem by name, you don't get the point. Same thing on the AP exam. You got to name the theorem by name. You have to say IVT. You can't just say like therefore there must be. You got to say by the IVT. Okay. Ooh. And some of you trying to tell me what the IVT says. Don't ever, ever do that. Ever. Don't ever say, the IVT says this. Okay, because first of all, I know what the IVT says. And the IVT doesn't say anything about a Y value having to be 11. Right? Anywhere in there. So if you say the IVT says that some Y value has to be 11, you just lied to me. Because the number 11 is nowhere in the intermediate value theorem. Right? Okay. So don't tell me what the IVT says. Do the problem. All right? Quoting theorems will never quoting a theorem or a formula never gets you diddly squat. All right? We already know the theorems and the formulas. We want to see if you can use them. Okay. That being said, a lot of you ignored this last part. You had to find C. C is the x value where the function equals 11. So you just set your function x squared plus x minus 1 equal to 11. So you get x squared plus x minus 12 equals 0. X, let's see, plus 4 minus 3. So you get x equals -4 or 3. Which one of these is our C? 3. Why is it only 3? Because this is an x value and it has to be in that interval. A lot of you got that. I was very proud of how many of you got that one because we haven't really talked about that very much. So well done. Okay. Almost done. We're moving along. Moving right along. Not equals equals. When you have a not equals equals piecewise function, do you need to do a left and right-handed limit? No. The not equals controls 99.9% of the graph of the function. The equals part is just a dot. So when you're finding the limit, you're just doing the not equals part. Don't try to be too specific. Just say f of x, and then you don't have to like get into trouble. Okay, so the limit as x approaches 1 of f of x is 5. You plug into the not equals part. It's 5. So that's the first part, find the limit. Use the definition of continuity to state why f of x is continuous or discontinuous at x equals 1. Whenever you see this, you're going to have to do 3 things. Number 1, you're going to have to find the limit, which we just did. Number 2, you're going to have to state the function value. So we find f of 1. What is f of 1?
2.
It's 2. It's where the dot is, right? F of 1 is 2. Then you answer the question, is this function continuous or discontinuous?
Discontinuous.
It's discontinuous. So you say f of x is discontinuous at x equals 1 because the limit as x approaches 1 of f of x does not equal f of 1. Anyone who tells me anything like there is a hole or there is a jump, you won't get any credit at all. You're not using the definition of continuity. All right? There is a hole or there is a jump is just a description of the graph that does not answer the question. So don't even go there. Just every single time you do continuous and discontinuous, the limit exists, the function is defined, they equal each other. Those are your three things. All right. Ready for the next one? Okay. Oh my goodness, this is a three-way piecewise function. Now, we're only looking at -1. If I call the parts of this piecewise top, middle, and bottom, which two parts are we concerned with? The top and the bottom? The middle. The middle. So even though like people will say, well, these are to the right of -1, yeah, but they're not approaching -1. This one like hits 1 and hits a wall. You got to go here because this is where the x values approach -1 from the right. Okay, so what do? Well, I would say the first thing we got to do is find the limit. Now, when you find a limit and you got a greater than, less than piecewise, what are you going to have to do? Left and right. So we're going to do a limit as x approaches -1 from the left. We're going to do a limit as x approaches -1 from the right. And then I'm going to use that information to find the limit as x approaches -1. From the left, do I use the top, the middle, or the bottom?
Top.
I use the top, because that's where the x values are to the left of -1. So I plug -1 into the top, I get 1 over -1, which is -1. From the right, do I use the top, the middle, or the bottom? I use the middle. The middle one, if I plug in a -1, I'll write it out for you. -1 minus 1 over 2. -2 over 2, that's -1. If the limit from the left is -1 and the limit from the right is -1, what's the limit? -1. No matter what. No exceptions. That is ironclad. If the limit from the left is -1 and the limit from the right is -1, then your limit is -1, no matter what. All right, we found the limit. Woohoo! Now we got to find what? The function. So many of you don't take the 3 seconds to write the function value. Write the function value. Because I'm looking for all three. I'm looking limit, function, equal each other. So in this case, f of -1, which we all know that's the top, right? Because that's where it equals. So, hey, f of -1 is -1. So the limit is -1. The function is -1, which means this function is continuous. So I would say the following. I'd say f of x is continuous at x equals -1 because, and now not many of you picked up on how a lot of you tried. I took it. If what you had was correct, putting it together, the correct way to write continuity from the definition of continuity is the limit as x approaches -1 of f of x equals, so we got to talk notation, equals -1, which equals f of -1. So you write what the limit is, and then this way it shows both of them are equal to it. Some of you wrote the -1 over here, and that's totally fine. I don't care. It's like a 3-way equals sign thing, 3-way equation. All right, public service announcement before we move on to the next problem. I did not take off for bad notation. Miss Grunwald did. I did not. She was shocked that my scores were not all like perfect because she said that the vast majority of points she took off were for notation. I made notes on a lot of your papers for bad notation, but I didn't take off points for bad notation. So here's the thing. Is that a good statement? No. You might as well just write this. Does this bother you?
Yeah.
Does it bother you? It should, like for a couple of reasons, but really it should because the root is empty, right? It makes no sense. This is nonsense, right? This is nonsense. You can't have a limit of nothing. Don't write a limit of nothing. That makes no sense. I'm going to sit there and put question marks every time, and on your test, I'm taking off every time. All right? You can't have a limit of blank. All right. That's me. I'm really getting hard on you guys today. That's okay. Your test is coming up. You need me to be strict. All right. Okay, so let's move on. No, we're not going to try. Okay, problem 10 was actually, I had rewritten problem 10, but I'd already printed your quizzes, so you got the original problem 10 before I did the rewrite, which is okay. So Ms. Grunwald, same thing. Like I printed all the quizzes, and then when I was looking over, I'm like, I think I really want to rewrite this problem and make it worded better. So in the future, like future students will get this problem 10. You were stuck with your problem 10. So either way, it was a good problem. So what you guys had to do was somehow find the derivative at, was it still this function? No? Oh, different function too. All right, well then let's do your problem 10. All right, so yours was find the derivative of, what's the function? X squared minus 5x at what x value? 2. At x equals 2, and then write the tangent line equation?
Yeah.
Okay, so technically find the derivative means the general derivative, but I was totally fine if you just used the derivative like at this point to find just the slope. I didn't care. So either way, however you chose to do it, if you did the limit as x approaches 2 of f of x minus f of 2, which is 4 minus 10 or negative 6 over x minus 2. So you get x squared minus 5x plus 6. So you get x, let's see, minus 3, x minus 2, cancel, and then you plug in a 2 and you get a slope of negative 1, right? That was fine. If you wanted to find the general derivative, so the general derivative, so f, this would be f prime of 2. If I found f prime of x, you didn't have to do both of these, understand. For video, understand. You don't have to do both. I'm just showing you both ways. Okay, so quiet down. A general derivative is the limit as h approaches 0 of f of x plus h minus f of x, I'm going to run out of space, over h. All right. The limit is h approaches 0 of f of x plus h minus f of x over h. So if I go ahead and do this, right? X squared plus 2xh plus h squared. Some of you are so bad with distributing your negatives. It's just awful. Please be careful with your negatives. All right. Okay. All right, so now let's cancel what cancels. So x squared and negative x squared is gone. 5x and negative 5x is gone. Remember, if you do it right, all your terms without h's should go away. So I'm just going to rewrite it cleaner. 2xh plus h squared minus 5h over h. Cancel an h from every term, and you get 2x plus 1, plus h minus 5. There we go. And then the limit as h approaches 0 would be 2x minus 5. Is that the equation of your tangent line? No. What is that?
That's the slope equation.
It's like your slope finding function, right? So to find the actual slope, you have to plug a 2 in, so you get negative. This way was way more work, but they were fine, either way. Okay, equation of a tangent line. What 2 things do we need for an equation of a tangent line? We need a point and a slope. So our slope is f prime of 2, which is negative 1. Our point, where do we get the point from? Okay, that's how we write the equation, but where do we get the actual point? Plug into the original function, right? The original function. The point is from f of 2. Well, it's not equal to f of 2. I'm just going to put a colon there so we say we're using f of 2. So it's 2 comma negative 6. And we got that, I found that like when we were doing this. So our equation, y minus negative 6, or y plus 6 equals negative 1 times x.
Oh my gosh.
Okay. And that's it.
Wait, so when you're finding, like, do you have to use like the plus b formula, or do you just do that?
That is the only formula for general derivative.
You can't do the minus exponent a.
That's for a derivative at a. A is a point. A is a number. Yes. That's for a derivative at a specific number. Yes. A, whenever you see A in a formula, A represents an actual number. It means put a number here. X doesn't. X is a variable. All right. We still have 20 minutes left. So I'm going to open this. I'm going to pause the screencast for a minute. For those of you watching the screencast, Miss Grunewald put a new worksheet on Schoology. So okay, so going into Unit 1. Oh, by the way, yeah, I know that's what I want. But thank you. So for just so you know, I'm going to show you right now. I am publishing all quizzes and answer keys. I think there might be a couple of little mistakes. No, maybe there weren't. I can't remember. I think on one of your quizzes, like quiz 2-2, there was an answer that was 20, and I think in my work I had like a 22. But the 20 was correct. So there might be a mistake or two in the answer keys. I will try to get new ones posted. All of the big quiz stuff is fine. Like, all of those answer keys are correct. I think there's just like one mistake on quiz 2-2. All right. That being said, under review materials. So we added some stuff. Okay, this right here, AP, AB, BC review questions PDF, that's the handout I gave you. Those, like, it's kind of a blend of multiple choice. Okay, I made an answer key to it. There's a graph that I have to add. I either have to hand draw it or type it by hand and then scan it or whatever. So I haven't done the graph part, but everything else is in there if you want to check. This is new. Chapter 2 sample exam. Okay. This because it's called sample exam doesn't mean it's like your test. It's just the test that came from the book, right? So it's literally like you can see like you can tell this is a scan, right? We just took a paper copy of the book's exam, right? Scanned it in. So anyway, but it's really good. Like it has all kinds of questions. It asks you about vertical asymptotes. You know what wasn't on your big quiz? Horizontal asymptotes.
I know.
Yeah. That is on your test. So be advised. Horizontal asymptotes are on your test. Okay? All right. Okay. Not like tons, but they're there. Right? Okay. All right. So anyway, so look at all of this stuff, right? Limits, information, practice it that way on the test. Book was kind enough to give us solutions, right? So if you want to work it on your own, you can, and then you can check your answers. They give you all the solutions, right? Okay, so that is something new that was added to Schoology. That's in addition to all the other stuff, which is good stuff that is added to, that is in Schoology, which is also in addition to the WebAssign work, which is in addition to the College Board work. Oh, and I got one more little tidbit of information about College Board. So we all joined this class, which is good. That's what we were supposed to do. Do not sign up for an AP exam yet. Right now, Mr. Rollin has all of you defaulted to undecided. The only people who have to sign up for an AP exam this fall, like during October, are the ones who are not taking BC. So if you are not taking BC, then you do have to sign up for the AB exam while you're in the class. If you're going on and taking BC next semester, you will sign up for the BC exam during your BC class. All right, so that's that. Okay, any questions on that? So if you need to sign up for an exam, you just log into the account and click. There's still a bunch of stuff, like there's a whole bunch of stuff that goes with it, not just to sign up for the exam on that little account, but you still have to pay for it too. There's all that stuff that goes with
Like,
it.
Mrs. Boone will tell us about that.
Believe me, yes. It would be bad to have the AP exam with like 4 students, right? Yeah, she's gonna tell you. Okay, good. Any other questions? All right, I'm shutting this down. Okay.